Hello everyone. Today we're going to get into the concept of backward design. We're going to talk about what it is and why it really is important when you're talking about instructional alignment to create effective instruction for our scholars. So without further ado, I shall share my screen and let's begin. So of course today, the title of today's session is backward design. What we're going to focus on in this session is the introduction to the term. We're going to talk about the 3 steps of backward design. Step 1 is what do we want the scholars to know? Step 2 is based on after the instruction, what do we want them to be able to show? And we're going to define what mastery looks like. And then step 3 is we're going to design activities. Okay, so we're going to talk about the beginning, the end, and all that fits in the middle. What is backward design? So I've coined my own definition in terms of backward design, and to me, it means beginning with the end in mind. When we're doing backward design is that we focus on content alignment that gets the results that we want based on the alignment of the rigor to STAR and things that prepare them for the next grade level. Okay, and also when it comes to backward design, students really need to understand and grasp the why behind their learning. They need to understand why the TEK we're talking about today is important for their future. So let's practice some backward design. Step 1 of backward design is essentially answering the question, what do we want them to know? And today we're going to focus on this example TEK. This is 4th grade math, 4.4a, which means the students will add and subtract whole numbers and decimals to the hundredths place using the standard algorithm. Before I open this note and show chart, this is something we usually do in what's called a collaborative planning meeting in which the upper grade levels 3 through 6, you'll be meeting with your colleagues that are on your grade level team and teach the same content as you. If you are self-contained, which that is 2nd grade and below, you'll be having a split collaborative meeting in which you're doing math half the time and then reading half the time. And a great resource to use for a deeper look into this student expectation is the TEKS Resource System website. So as I go to the know and show chart, this know and show chart presentation has all the TEKS from 4th grade, so there's quite a bit of slides, but currently I'm on slide 17 of this. And so this is 4.4a, all of the conceptual knowledge that comes with the TEK. And so this, remember, we're focused on step 1 right now. This is what we want them to know. Of course, place value, especially when it comes to decimal numbers, we will have covered a unit of place value before introducing this concept. We want them to know properties of operations, specifically adding, subtracting. They need to know decimal placement, lining up the place value after the decimal, borrowing and regrouping, and things like, so when it comes to the whole numbers, subtracting across zeros. And sometimes when you'll see scholars, when they want to subtract, they'll still start in the ones place versus the greatest place value. A big one is vocabulary teaching, definition, and context, which is different, some, most, or greatest, comparison, or how many more, or how much more. The standard algorithm, of course. Things like that problem solving vocabulary, again, when it says each means every single one. When to know that it is a one-step problem versus a multi-step problem. When it gets into more of the complex problems, students may need to know when to ignore unnecessary information or decipher important information. And they also need to know how to pull information from a table in some cases. And so some misconceptions that they may have, because this has to deal with the know part, is operational relationships, addition and subtraction of whole numbers and decimals, the difference between a comma and a decimal, possibly missing the 2nd or 3rd and 4th step in a multi-step problem, multi-step with place value concepts, and vocabulary with least and most, because it may ask, if they're given a table, okay, what is the difference between the greatest number and the least number, or the highest number and the least number, etc. And then there's also a lot of scenarios in which students have to place what we call invisible zeros after the decimal for whole numbers. If they're doing 4 minus 2 and 2500ths, they have to place 4.00 in order to subtract properly. So that was basically the know part of the TEK. And now we're going to get into step 2, which means what do we want the scholars to be able to show as we move through the whole lesson and we get to the end of the lesson. What is it that we want them to show mastery in? And obviously, based on what we just looked at, we cannot teach all of that in one day. So this is why 4.4a requires obviously more than one day of instruction. But for this particular day, let's just take one day. Okay, the first day of instruction will require a really heavy focus on the basic algorithm and to emphasize place value. So a sample learning objective would be that scholars will be able to find the sum and difference of decimal numbers by using the standard algorithm. And we also may throw a one-step problem in there just so they are getting exposed to that problem-solving vocabulary that we need them to know. So in addition to doing step 2, the demonstration of learning, or what we call an exit ticket, is we have the learning objective, and then we have what's called the exit ticket. And does the beginning match the end? Is there alignment in there? That's the most important piece. So this is a sample demonstration of learning. You've got adding on number 1, adding with decimals. On number 2, you've got subtracting with decimals. And then on number 3, this is a one-step problem in which they're going to have to know how to subtract, because in the question, they're making a comparison. So that's a big deal. If we go back to the show part of the chart, students may need to create their own place value chart just so they can make sure that they are aligning up their place values correctly and that their decimals are not misaligned. This Quest is a problem-solving model that we use. And so when it comes to problem solving with all that vocabulary and everything, and they need to make visuals, it would help them to draw a bar diagram. Of course, the standard algorithm is in there. And then things like the griddable, which is what the griddable looks like on the STAR testing format when it comes to the decimal ones, tens, hundreds, and then tenths and hundredths after that. They just need to know that's just a test taking formality that they need to know that we can include in our lessons. And then that the students need to be able to know how to line up decimals, of course. And so then we've listed some resources at the bottom. And that's what we need them to show. Okay, now we are on the last step of backward design, step 3, which is designing the activities and the formatting of the lesson. So I'll share my screen again. The way we teach at this school is we follow what's called a gradual release method. We have I do, we do, you do, in which the teacher models instruction, the students are given an opportunity to work together, and then there's a independent practice piece, and then finally at the end is the demonstration of learning, their exit ticket. So on here we've listed what the teacher will model, and that is all aligned to the demonstration of learning, because we definitely want to focus on the importance of place value and alignment when it comes to the adding and subtracting of decimals, knowing the standard algorithm. And then we also want to focus on that vocabulary of the problem solving. So because the demonstration of learning exit ticket has a subtraction problem, we're probably going to want to model a subtraction problem very much like the one in the DOL for short. Then in the guided instruction section, which this is the we do collaborative piece, which students are working together and the teacher serves as the facilitator. Students will solve standard algorithm problems. Some groups will solve addition problems, and some will solve subtraction problems. And then by the time it's up, we will allow each group to show and model for their class or be the teacher, so that they can really internalize that content by teaching other people. And then during the independent practice piece is when we want to utilize the strategy of aggressive monitoring, in which the students are working on their work independently, and the teacher is walking around looking to make sure that they're doing things such as lining up their decimal place value and each letter of quest so that it's clear. And then not only will they solve one addition problem and one subtraction problem, they're also going to solve a word problem, of course. And so that concludes backward design. Thank you.